streaming. Clock start. All right. Where was I? Cipher query language. Let's just read these and be done with them. I need water. I'll be right back. Okay. And the other parts of the query can use those names to create edges between the vertices using an arrow notation. Well. Oh. I guess it won't matter because I need to make chicken anyway. Okay. Graph queries in SQL. Recursive common table expressions with the recursive syntax. Finding the names of people who. With recursive. Wow, it's so long. In USA, in Europe, born in USA, lives in Europe. Then you select them all from, and then you join. Brutal. If the same query can be written in 4 lines in one language but require 29 lines in another, that just shows the different data models are designed to satisfy different use cases. It's important to pick a data model that is suitable for your application. Triple stores and Sparkle. The triple store model is mostly equivalent to the property graph model, using different words to describe the same ideas. Well, it's a good thing we're have a whole section on it then. It's literally the next sentence. It is nevertheless worth discussing because there are various tools and languages for triple stores that can be valuable additions to your toolbox for building applications. Sure. In a triple store, all information is stored. Form a very simple 3-part statement. Yeah. If you read more about triple stores, I'm zoning out. You may get sucked into a maelstrom of articles written about the semantic web. The triple store data model, I've read about this. The triple store data model is completely independent of the semantic web. For example, Datomic is a triple store that does not claim to have anything to do with it, but since the two are so closely linked in many people's minds, we should discuss them briefly. The semantic web is fundamentally a simple and reasonable idea. Websites already publish information as text and pictures for humans to read. So why don't they all also publish information as machine readable data for computers to read? The resource description framework was intended as a mechanism for different websites to publish data in a consistent format, allowing data from different websites to be automatically combined into a web of data, kind of internet-wide database of everything. Overhyped in the early 2000s, hasn't shown any sign of being realized in practice. Cynical about it, has also suffered from a dizzying plethora of acronyms, overcome standards, and hubris. Or if you look past those failings, there's a lot of good work that has come out of the Semantic Web Project. Triples can be good internal data model for applications. RDF data model. Which is Resource Description Framework. Alright, I just feel like these are so like specific to certain technologies that it's like hard to take much away from this. Like I'm looking at Sparkle query language syntax right now. The foundation data log. Even older than Sparkle or Cypher, having been studied extensively by academics in 1980s, it's less well known among software engineers, but is nevertheless important because it provides a foundation that later query languages build upon. In practice, Datalog is used in a few systems. For example, in the query language of Datomic, Cascalog is a Datalog implementation for querying large data sets in Hadoop. Let's see here. Datalog's data model is similar to the triple store model, generalized a bit. Instead of writing a triple, we will write a predicate subject object. Name North America, USA, United States, USA country, within. Huh. like in Cypher and Sparkle. Data log approach requires a different kind of thinking to other query languages discussed in this chapter, but it's a very powerful approach because rules can be combined and reused in different queries. It's less convenient for simple one-off queries, but it can cope better if your data is complex. All right, so in summary, I thought we'd never get here. Data models are a huge subject, and in this chapter we've taken a quick look at a broad variety of different models. We didn't have space to go into all detail of each model, but hopefully the overview has been enough to whet your appetite to find out more about the model that best fits your application. Historically, data started out being represented as one big tree, the hierarchical model, but that wasn't good for representing many-to-many relationships, so the relational model was invented to solve that problem. More recently, developers found that some applications don't fit well in the relational model either. New non-relational NoSQL data stores have diverged in two main directions: document, graph. All three models are widely used today, and each is good in its respective domain. One model can be emulated in terms of another model, but the result is often awkward. Sure. That's why we have different systems for different purposes, not a single one-size-fits-all solution. One thing that document and graph databases have in common is that they typically don't enforce a schema for the data they store, which can make it easier to adapt applications to changing requirements. However, your application most likely still assumes that data has a certain structure. It's just a question of whether the schema is explicit, enforced on write, or implicit, assumed on read. Each data model comes with its own query language or framework, and we discussed several examples. Although we have covered a lot of ground, there are still many data models left unmentioned. To give a few brief examples, researchers working with genome data often need to perform sequence similarity searches. What is that? Which means taking one very long string representing a DNA molecule and matching it against a large database of strings that are similar but not identical. Oh, interesting. GenBank, okay. Particle physicists have been doing big data style, large scale data analysis for decades in projects like the Large Hadron Collider, LHC, now work with hundreds of petabytes. At such a scale, custom solutions are required to stop the hardware costs from spiraling out of control, and then full text search is arguably a kind of data model that is frequently used alongside databases. Information retrieval is a large specialist subject that we won't cover in great detail in this book, but we'll touch on in search indexes in chapter 3. We have to leave it here for now. In the next chapter, we'll discuss some of the trade-offs that come into play when implementing the data models described in this chapter. No way, dude. More data models? So, something that's interesting is this summary, I feel like, is pretty legit. Like, I almost wonder... whatever. Okay, so we're moving on to chapter 3. So the rest of chapter 2, and like even parts of it that I've already kind of written down, was really just examples or demonstrations of how they can be different. Like the same solution can be done in different how do I get out of flashcards, dude? What is this? Here. So chapter 3. Let's do notes. This is a funny quote. On the most fundamental level, a database needs to do two things. Okay, so I also want, let's see. So we had a chapter 1 summary. Oh, chapter 2 summary. On the most fundamental level, a database needs to do, oh, I see. So we've defined our data model, and now we need, we've defined our data model, and now we need to store it and retrieve it. So on the most fundamental level, a database needs to do two things. When you give it some data, it should store the data, and when you ask it again later, it should give the data back to you. In chapter 2, we discussed data models and query languages, i.e. the format in which you, the application developer, give the database your data and the mechanism by which you ask for it again later. In this chapter, we discuss the same from the database point of view. How can we store the data that we're given, and how can we find it again later when we're asked for it? Why should you, as an application developer, care how the database? You're probably not going to implement your own storage engine from scratch, but you do need to select a storage engine that's appropriate for your application from the many that are available. In order to tune the storage engine to perform well on your kind of workload, you need to have a rough idea of what the storage engine is doing under the hood. Okay, so let's do this. Let's try making this work well. So in here for chapter 3, find So, I mean, this PDF has 600 pages. How many pages? Um, Watch, it's gonna find them. Okay. So, how many? I don't know. Can you guys see this right now? No, I'm talking to ChatGPT. Where's? It's super annoying. Oh wow, it's not here? That's so annoying. Uh, okay, let's take a second. So I'm starting a new section, but I want this to get better. So let's see. GPT prompts for a tutor. There was like a GitHub repo. Let's see. Mm. Um, Garbage. It's not. What's going on here? Hmm. Whoa. Prompts for EDU, students prompts, tutor. Purpose. The prompt outlines the role of an upbeat and encouraging AI tutor. So the student asks about the student's desired level of learning and prior knowledge. Hmm. Well, this is kind of cool. Okay, well, this is a waste of time right now. I don't know why I can't find my stuff, you know? Uh, okay, well, let's just re-upload it. That's what it's telling me to do. But then it just lost context. Like, in the beginning, it said it was gonna do. Like, what are you doing, dude? Ugh, God. Well. Hmm. I still haven't figured out how to use this thing. Alright, well, there's 10 minutes left. So, storage and retrieval, we'll talk about data structures that power your databases, hash indexes, SS tables and LSM trees, constructing and maintaining SS tables, LSM trees, performance optimization, then another kind of tree, B tree, making them reliable, B trees versus LSM trees, the advantages and downsides of LSM, and then some other indexing structures. And then transaction processing or analytics, data warehousing, stars and snowflakes, schemas for analytics. Column-oriented storage, that's cool. We use Snowflake at work, so that'll be nice. Column compression. Okay, so this is kind of meaty, I think. sort, order, and column, writing column oriented, storage, aggregation. Okay, so I think this chapter is going to be hard actually. Okay, so let's make sure. Whoa, 15 do? What? Let's make sure we aren't forgetting anything by doing the flashcards. And then chapter 3 is pretty beefy. So, what are the advantages of the document model? I didn't even say it yet. I didn't read anything. So, the advantages of the document model: locality, flexible schema, potentially hierarchical, don't have to do joins, schema is inflexible, nested, hierarchical, data that fits naturally. All right, we'll say that's good. Duplication in data models refers to when the solution stores human relevant information multiple times. Yeah. A declarative language is when you literally tell the computer what to do. So you provide it an instruction set rather than a description of what you would like to happen. Oh. Wow. I did the opposite. Okay. Schema on write is what we think of with like relational models where we we define the data ahead of time and guarantee some values will be populated. Versus schema on read where we can kind of put whatever we want in and then we figure out what it is when it comes out. Schema is explicit and the database ensures all written data conforms to it. What are the key characteristics of the relational model? Joins, foreign keys, tables, rows, foreign keys, SQL for querying, normalization and strong consistency in decades. We'll say it's good. What is the benefit of declarative query languages like SQL? You can do performance optimizations in the background and nobody has to know. And then those optimizations can be used automatically because of that. That's a weak explanation. It provides an abstraction so that developers can make changes. We'll just say changes under the hood that impact all queries without basically changing the API. No. What is the graph data model best suited for? Social networks. Basically anything that has a lot of many-to-many relationships. So if you want to relate data to many different things, you should use a graph. Recommendation engines, network topologies. So that's complex relationships. I'll just say this is hard. What are the downsides of imperative queries embedded in application code? They're hard to debug, and they're tightly coupled with business logic. which can be a problem. Error prone, harder to optimize. Not harder to debug, harder to optimize. So I got 1 out of 3, then we're going to say hard. What is the trade-off between normalization and denormalization? So normalization means we get less typos, better searching, and potential pre-filling of fields. Denormalization means better data locality. We don't have to join with any tables, but human relevant information is stored multiple times. Schema as read is when there's no predefined schema, so we have to validate it as it comes out. Only interpreted when the data is read. What is a data model and why is it important? A data model is the structure. What is a data model? It's the way we think about the data, and it's important because it determines how we think about the problem and therefore the solutions. An imperative language. Didn't I just do this one? No, I did declarative. So imperative is when you literally give the computer a set of instructions. Certain operations in a certain order or instructions. Shredding is when you take a document and you break it into multiple tables. How does a graph model represent data? With edges and nodes, vertices. Edges and nodes. Yeah. Nodes represent points of data, and edges represent the relationships between the two. Nodes and edges, cool. What is the document model? When is the document model a better choice than relational model? When you have an application whose the application data model nicely fits into a document. There's not a lot of one-to-many relationships, and maybe you need flexible schema. Data is frequently read as a whole. Relationships are simple. Yeah, simple. You need schema flexibility. Yeah. And data duplication can be taught. Okay, so I'll say that's good. MapReduce is a programming, is it paradigm? Is paradigm the right word? Paradigm. A typical example or pattern of something. Yeah. It's a programming paradigm where basically we give it snippets of code to run on each piece of data as part of the query. Something like that. Model for processing large amounts of data. No. Alright, that was it.